In this video, you'll get a quick overview of the Environmental Toxins Test. I'll explain the Vibrant advantage and technology used. Then I'll walk through each section of the test, highlighting key features. I'll also suggest complementary tests and end by summarizing the key takeaways and where to go for additional information. Environmental toxins are ubiquitous. The Environmental Protection Agency inventory contains roughly 84,000 chemical substances, many of which have limited testing for their effects on humans or the environment. Furthermore, chemicals no longer authorized for use in the U.S., like DDT, continue to persist in the environment as persistent organic pollutants. Although the EPA is working to decrease levels, environmental toxins remain a serious problem. In fact, toxin exposures have been associated with several medical conditions and diseases. Common areas of concern include cancer, cardiovascular disease, neurological conditions, immune dysfunction, negative reproductive effects, and a host of relevant symptoms and negative health outcomes. Vibrant's Environmental Toxins Test is an easy at-home urine test that uses the gold standard liquid chromatography mass spectrometry to measure 38 environmental toxins, providing robust insight into environmental toxin exposure. Liquid chromatography with tandem mass spectrometry is a powerful analytical technique that combines the separating power of liquid chromatography with a highly sensitive and selective mass analysis capability of quadrupole mass spectrometry. The mass spec machine we use detects elements down to the parts per quadrillion level. So how small is parts per quadrillion? Well, if you had a pie and cut that pie into a quadrillion pieces, that's a 1 with 15 zeros after it, the Nexine mass spec instrument Vibrant uses can detect one tiny piece of that pie. Now, that's pretty powerful stuff. Before we dive into the actual report, I want to remind you that you can choose how much information to include in the report you download for yourself or the report you share with your patients. You have 3 options: summary with interpretation, and full report. I'll be going over the full report in this video as it is the most comprehensive. Let's start with a quick overview. The Environmental Toxin Sample Report includes a cover page, introduction, summary, and then the full list of analytes, which includes all 38 environmental toxins across 8 categories. The cover page lists the sample type and results interpretation key. The introduction page includes the methodology and interpretation of report, and I highly recommend reading this page, especially the part of the introduction where it says, quote, reference ranges for tests flagged with a caret were determined based on NHANES data, if available, and other reference ranges are established based on urine samples from 1,000 apparently healthy individuals. And also the part where it says, the level of environmental toxins is shown with 3 shades of color, green, yellow, and red, and explains which percentile each color corresponds to. The summary shows the high-risk results like bisphenol A and moderate results like atrazine and glyphosate. Then the full report lists all 38 environmental toxins across 8 categories, including environmental phenols, herbicides, a mitochondrial marker, other markers, parabens, pesticides, phthalates, and volatile organic compounds. Okay, starting at the top. Phenols are a group of chemicals used ubiquitously in consumer and personal care products, pesticides, and as preservatives in food and beverage processing. Markers include bisphenol A, commonly called BPA, triclosan, and 4-nonylphenol. Note that the results are reported as both a number and plotted graphically so you can visually see how high or how low your patient's results are. Results in green correspond to the 0 to 75th percentile and indicates mild exposure. A yellow result corresponds to the 75th to 95th percentile, indicating moderate exposure. And a result in the red corresponds to the greater than 95th percentile, indicating exposure is higher than 95% of the population. For example, this patient has elevated levels of BPA, which is very common. Good news, they've been able to reduce their exposure from 18.19 in February to 7.14. Looking at the graph, their light blue pin indicating past exposure is on the far left, while the dark blue pin indicating current exposure is much closer to the orange. Ideally, this patient should get their result below 5.09, which is the reference range. and note that the reference range is set at the 95th percentile. If you want to learn more about the toxins showing moderate and high exposure, like BPA and atrazine, simply scroll back to this report summary and read the interpretive comment. The interpretive comment includes the background, associated risk, possible sources, and detox suggestions. Moving on. Herbicides are chemicals used to control the growth of weeds, herbs, and other undesirable vegetation. Markers include 2,4-dichlorophenoxyacetic acid, atrazine, atrazine mercapturate, and glyphosate. Thioglycine is a mitochondrial marker. Since toxins may contribute to impaired mitochondrial function, elevated levels of thioglycine provides evidence of mitochondrial dysfunction. The others markers category includes markers that simply don't fit into the other categories, such as diphenylphosphate or DPP, and acetyl S2-carboxymoyl-ethylcysteine, and perchlorate. Parabens are synthetic chemicals used as a preservative in the cosmetic, pharmaceuticals, food, and beverage industries. Parabens are preferred because they have a neutral pH, are tasteless and odorless, have effective antimicrobial activity against fungi and gram-positive bacteria, and do not result in product discoloration or hardening. Markers include methylparaben, propylparaben, butylparaben, and ethylparaben. Now, while this patient does not have elevated levels, paraben exposure is very common. According to this 2023 study, the average woman uses 12 different personal care products containing 168 unique chemicals each day. Pesticides are a group of chemicals used for the destruction of insects, weeds, fungi, and bacteria, and this includes organophosphate pesticides, the pyrethroid pesticides like 3-PBA, and organochlorine pesticides like DDT. Note that DDA is a metabolite of DDT. In fact, many of the markers on the environmental toxins test are metabolites of the parent compound. This indicates that the toxin entered the liver, underwent biotransformation via phase 1 or phase 2 detoxification, and then ended up in the urine as a metabolized component. You can check out the Environmental Toxins Guide to learn more. Phthalates are colorless, odorless, oily liquids that do not chemically bind to materials. They're often categorized as a group of chemicals called plasticizers, which makes plastics more flexible and durable. They've been labeled the everywhere chemical due to their ubiquitous nature in our daily lives, from children's toys to art supplies, fragrances, and cosmetics, as well as housing materials and new upholstery. They're usually responsible for that, quote, new car smell. They're even found in medical equipment and medications. The EPA defines volatile organic compounds as a category of compounds that have a high vapor pressure and low water solubility. They're often synthetic chemicals used in the production of paints, pharmaceuticals, refrigerants, and other industrial products. They include compounds like xylene, styrene, benzene, propylene oxide, acrylonitrile, ethylene oxide, and MTBE. As a reminder, Vibrant Environmental Toxins measures mainly metabolites of these parent compounds, basically what comes out in your urine after your liver turns these oily compounds into water-soluble metabolites. For example, 2-MHA, 3-MHA, and 4-MHA are all metabolites of the parent compound xylene. If you want a refresher on liver biotransformation and detoxification, check out pages 50 through 55 of the Environmental Toxins Guide, or consider watching the YouTube video linked by QR code on your screen. One last thing to point out is that all urine tests should also measure urine creatinine. This is because urine can have varied concentrations. Sometimes it's pale yellow and sometimes it's the color of a school bus. Good news, urine creatinine is constant. So all environmental toxins are normalized to urine creatinine to account for urine dilution variations. As we talk about complementary tests, I want you to think about Dr. Sidney Baker's TAC rules. Rule number 1. If you're sitting on a TAC, it takes a lot of aspirin to make the pain go away. In other words, it's difficult to heal if you don't identify the root cause of your symptoms. Rule number 2. If you're sitting on 2 TACs, removing one does not necessarily result in a 50% improvement in your symptoms. In other words, sometimes there's more than one toxin contributing to your symptoms. In addition to environmental toxins, also consider exploring exposure to mycotoxins, heavy metals, and PFAS to investigate and also reduce the total toxic burden. Consider hepatic function and renal function panels to investigate liver and kidney function, which impact detoxification and elimination. the gut zoomer to investigate microbial overgrowth burden, intestinal hyperpermeability, and or elevated beta-glucuronidase that's impacting detox and elimination. Micronutrients to assess intracellular and extracellular nutrient levels, as many environmental toxins deplete critical nutrients such as antioxidants and minerals, and to assess for the adequacy in micronutrients required for phase 1 and phase 2 detoxification pathways. The oxidative stress profile to assess how much toxin exposure is accelerating aging in your patients, and hormones, be it serum, saliva, and or urine, to investigate environmental toxin impact on endocrine and reproductive symptoms. In conclusion, the Environmental Toxins Test measures 38 environmental toxins so you know if toxic burden is contributing to symptoms like neurological, headaches, difficulty concentrating, gastrointestinal symptoms like diarrhea and bloating, endocrine imbalances, including reproductive problems, or maybe just fatigue. By identifying your patient's exposure to environmental toxins, you can devise a plan to reduce their exposure, increase their elimination, and promote healing today. To learn more, visit the link in the video description, and if you can't find it, you can use the QR code or URL on this page to visit us. If you have any questions, please ask them in the comments below this video. Thanks so much and have a vibrant day.